perimeter and area again. And our learning objective is to recognise that shapes with the same area can have different perimeters and vice versa. What does vice versa mean? And the other way around, yeah. So they can have the same area, different perimeter, or same perimeter, different area. Good. Okay. So before we think about that, let's have a look at these two shapes on the board. And I would like everybody at home and everybody in here to write down for me what the perimeter of that shape is. What's the perimeter?
The outside edge.
The distance all the way around the outside. So what is the perimeter? What is the area of that rectangle? What is the perimeter? What is the area of that square? Have a go. Perimeter and area, both. Both. Good. Don't forget your units of measure. Are they centimetres, metres, kilometres, millimetres? Good. Well done. And have a look at the slide. So, to find the perimeter, the distance all the way around the edge. There are different ways of doing it. You could think to yourself, that's 12, that's 12. Two 12s are 24. That's 4, so that was before. Two 4s are 8, and add them together. Or you could add 12 and 4 together, which is
That'll be 16.
16, and then do two lots of 16s. You've got that twice, which is 32. And then the area equals length times width. So 12 times 4 is 48 centimetres squared. Okay. The other one, perimeter again. 8 and 8 is 16, you can double that. It doesn't matter which way around you use to calculate it, but as long as you get the correct answer, which is 32. So you can just do 8 4 times, you can do lots of 16, or you can just do 8, 8, 8 and 8. It's up to you. And the area, 8 times 8 is 64. So, what do you notice about the perimeter and area of those two shapes? What is though? You're on the right lines, but you need to be a bit more precise and tell me what's equal.
Them two, both shapes, perimeter, are both the same.
Right, good. The perimeter is the same for that shape and that shape. They've got different measurements. The perimeter is the same. Okay? But what do you notice about the area?
But they're completely different.
Yeah, the area is different. So, even though the perimeter is the same, the area, the amount of space it takes up, is different. That one takes up far more space than that one. Okay? Right, so I would like you to have a go at the next example and see what you notice about the area and perimeter. Have a go on your whiteboards. Don't forget the unit of measure, so it's in metres this time. Well done. Right. So, bullet boards. Good. What do we notice about the perimeter of those two shapes and the area?
No, the area is the same and the perimeter is different.
Right, the area is the same for both. It doesn't look it, does it? When you look at them, you can't really see that that is taking up the same amount of space as that. But it is. But the perimeter, the distance all the way around the edge, is different. Okay. Can anybody see any links there between the measurements?
7 times 5 is 35 and 10 times 3.5 is 35.
Say that again for me, sorry.
7 times 5
Yeah, it's 35. Yeah, sorry, and that's, yeah.
and
You've
10
got,
times 3.5.
yeah, yeah, good. But can anybody see any links between, say, that measurement and that measurement and that measurement and that measurement?
The 5 and the 10 are half each other.
Yeah, the 5 is actually half of 10. 7 is double 3.5. Interesting, isn't it? The measurements actually double over. So double and then half. Yeah? And it's giving you the same area. Interesting, might be an interesting one to investigate. Okay. So today you are going to investigate patterns, places where there aren't patterns, and you're going to look at perimeter, you're going to look at area and see when they are the same and when they are different, and maybe even spot one or two patterns along the way. Okay?